Welcome to MLonAzure.com, where we talk about machine learning concepts on Azure. In today's episode, we're going to talk about how do you go about training tens of thousands or hundreds of thousands of machine learning models in parallel. And then how do you use those models to actually perform scoring on new data as it comes in or to do it in batch. The four main concepts that we're going to cover today are pipelines, parallel run step, compute cluster, data store, and data set. Pipeline, in this case, we're referring to the Azure Machine Learning Service pipelines, which allow you to automate the training as well as the scoring of machine learning models. Within a pipeline, you essentially create steps. There are Python script steps, R script steps, as well as parallel run step. Parallel run step is what we're going to concentrate on. There are many other types of steps that you can use. But for parallel run step specifically, what we do is we take a Python script file and we run that on every node of your compute cluster. Within the compute cluster, as the file is running, it will tap into the data store and it will grab a file that gets trained on the compute cluster node, and then it registers a model for that file specifically. So essentially, think about if you had 10,000 files or 100,000 files, where each file is split such that it's supposed to create its own machine learning model. Then what will happen is the compute cluster will take that same Python script file and it will run it against each one of those files to build a machine learning model for that file and register it. And it does all of that in parallel thanks to the parallel run step, which now means that we can build tens of thousands or really hundreds of thousands of machine learning model in parallel across this compute cluster in a timely fashion. The same concept can then be applied when we're scoring new data. So if we get a large batch of data and we want to go ahead and score that data across those multiple nodes, across those multiple machine learning models that were created, then we can again use the parallel run step. Note that for the parallel run step, it takes in a Python file, but it can also take a Python file that uses AutoML. So if you wanted to take AutoML and now run it against 100,000 files and run that across the cluster, ParallelRunStep can do that for you as well. Let's take a look. Welcome to MLonAzure.com. Here we're looking at the blog article that talks about Azure Machine Learning Service pipelines. It gives you a quick picture of what the pipelines look like in the Azure Machine Learning Studio, and then it gives you a brief description of it. And as we scroll down here, these are the main steps or the most common steps that are typically used when constructing a pipeline, such as an AutoML step, a data transfer step, which allows you to move data from point A to point B. Underneath, it actually uses Azure Data Factory, which is very neat. And as we scroll down, we'll see the last step that we have listed here, which is the newest one, is called a parallel run step. And that's what we're going to concentrate on today. As we take a look at parallel run step, we can go into the actual blog article that talks about this. All right, this is the blog article that talks about the parallel run step. So MLOps, training and scoring models in parallel. As you can see here, from the image, what we have here is an AML pipeline, and then within the AML pipeline, you have the parallel run step. The parallel run step, again, has a source reference and a destination reference. And the idea of the source reference, that's where it's going to go and get all of its data to actually train. And then the destination reference is where it's going to actually register the model. Or in the case of actually doing model scoring, the source would be where it gets the data to score, and the destination is where it actually goes ahead and saves the scored output. This runs across a compute cluster as seen on the bottom of the chart, and you simply pass it a Python file. So to take a look at model training first, let's scroll down. And here in model training, we see what this looks like. So essentially, again, you have your parallel run step with the compute target. This compute target is an AML compute cluster. And as you can see by the green arrow, it can actually be scaled out. So if you have many, many models or many files that you're adding, then you can go ahead and increase the number of nodes in your compute cluster, assuming that you have enough cores in your subscription to allow for that. And if you don't, it's very easy to request more cores. We essentially take that file and we copy that file to every one of those compute node clusters, and we run the file pointing to a different data source file for you to do the machine learning training. And once the model training is done for that file, then that gets saved inside of the model registry. So let's talk about that again. You have a compute cluster, and we take this Python script file and run it on each node of the compute cluster. Then within that compute node, it reaches out to the data store and it gets a specific file that it does the model training for. And now you have a machine learning model for that specific file that then gets registered in the model registry. Meanwhile, the next node of the cluster did the same thing, the next node did the same thing, and so on and so forth. And as each node completes, then it goes ahead and gets another file. And next thing you wait, and now you have 100,000 models that are registered. So now in this section, we're going to talk about model scoring. And model scoring happens the same exact way, where you have a Python script file that knows how to do the model scoring. In other words, it knows how to retrieve the proper machine learning model and then run the model.predict on that file. So across the cluster, that file gets sent to each one of those nodes, and then each one of those nodes goes and retrieves new data. And as it retrieves the new data, then it goes ahead and calls model.predict, gets the score, and then it saves that score in an output file. Now to put it all together, what we've essentially created is a pipeline for training and a pipeline for scoring. Sometimes those two pipelines can be merged into just one pipeline. But the key here is that we've built a pipeline that takes a Python script file and does model training, takes a different Python script file and does model scoring. That file could be a custom Python script that you write that does your own custom algorithms, or it can be an AutoML algorithm behind the scenes. So you can call Azure Machine Learning Service AutoML, create the AutoML configuration, and then does the model training and scoring based on those models. Now, to help with all of this, the product team has created what we call the Many Model Solution Accelerator. So let's take a look. This is the Many Model Solution Accelerator the product team has put together. And the idea here is to give you a code sample that will show you how to use the parallel run step both for AutoML as well as with your own custom script. The product team has also provided a video walkthrough of the Solution Accelerator. This is the Azure AI blog, which you can get to through the Microsoft Tech communities, where we have blogged about the Many Model Solution Accelerator. So as you go into this Many Model Solution Accelerator, then you can read all about the Many Model Solution Accelerator and learn about it, and ideally apply the code sample that's there in the GitHub repository, but then also go ahead and apply your own data and your own script with this code. Good luck and have fun. Thank you for tuning in on another episode of MLonAzure.com. We really hope that you found this content useful. Please provide us feedback so we can continue building new content for your consumption. Thank you so much.